We're looking at piecewise functions again. This video is going to deal with evaluating a piecewise function. So we're looking at the piecewise function that has f of x equal to 3 if the x values are less than -2. So if you look at the graph, that's this portion here, less than but not equal to, so there's an open circle and it's a horizontal line. So everything that has an x value less than -2, the y or the f of that number will just be 3. For x values that are between -2 and 5, including those endpoints, the f of x is equal to x plus 2. And we can see that's this point, or this section of the graph, this piece of the graph. And then the last piece of this graph is for x values greater than 5. The equation is negative. This is written incorrectly. This is negative 1/2 x plus 3. It goes down 1 over 2, and if I extended this, you could see that the y-intercept would be at 3. So when I'm evaluating a piecewise function, I may not have the graph as well as the equation. It's pretty simple to find it from the graph. Find f of -7. I find -7 on the graph, and I go up to where it meets the function, and that's over at +3, so my answer is 3. But if I'm not looking at the graph, I need to look at the domain restrictions. So -7, I need to find which of these inequalities -7 applies to. Is -7 greater than 5? No. Is -7 between -2 and 5? No. Is -7 less than -2? Yes. So because -7 is less than -2, the f of x is equal to 3. I don't have to plug in anything because I have no x value in this equation. It's just all of the y values will be equal to 3. Now the next one asks you about f of -2. So is -2 greater than 5? No. Is -2 less than or equal to -2? Yes, it's equal to it. That's why it has a closed circle over here. So for -2, I'm going to use the function x plus 2. So I'm going to use x plus 2, and I'm going to plug in -2. So -2 plus 2 equals 0. So my answer is 0. And we can see that the graph supports that right here. At -2, the y is 0. Finding f of 1. Again, 1 is less than 5. So it's in this interval between -2 and 5. So I can plug in 1 to x plus 2. So 1 plus 2 is 3. So f of 1 is equal to 3. And if I look at my graph over here, come up, and you can see that the y value is 3 when the x is 1. F of 6. Is 6 greater than 5? Yes. So because 6 is greater than 5, I'm going to use -1/2 x plus 3. -1/2 times 6 plus 3. -6, oh, sorry, it's -3. -3 plus 3, which equals 0. And again, if we go to our graph, it supports that because over here it's +6, the y value is 0. What about 5? Does 5 qualify as greater than 5 or less than or equal to 5? 5 is less than or equal to 5. So we're going to plug it into the x plus 2 equation. So we're going to use x plus 2. So 5 plus 2 equals 7. So f of 5 equals 7. Here this should say f of 6 equals 0. F of 1 equals 3. F of -2 equals 0. And f of -7 equals 3. And lastly, 10. Is 10 less than -2? No. Is 10 between -2 and 5? No. Is 10 greater than 5? Yes. So I'm going to use the -1/2 x plus 3. So it's -1/2 times 10 plus 3, which is -5 plus 3 equals -2. Apologize about the bell. Time to go teach class.